Hi, my name is Isabel, and my research focuses on the evaluation of naturally absorbent materials for menstrual health maintenance in low-resource settings. A lack of menstrual health maintenance, otherwise known as MHM, supplies in low-resource countries has a profound effect on the lives of girls. In low-resource communities, there are few sanitary options available. As a result, girls are forced to miss school. 28% of the students in India do not go to school during their period due to lack of facilities and sanitary materials. These also prompts health concerns as many girls use unsanitary materials like old rags, husks, grass, sand, or newspapers. Of the women using cloth as absorbents, half of them use the same cloth for more than a month. High costs and unavailability of sanitary pads is the prime reason for women and girls in India to not use sanitary pads. Given this motivation, our research objectives are to explore easily available, sustainable, and inexpensive materials, and to understand how they can be used in a sanitary pad design. The methods we use to test our objectives look at using sawdust as an absorptive media in a sanitary pad. We used physiological saline as our model for menstrual fluid, as it has the same salinity. In our experiments, we looked at the change in mass of sawdust over time as it was introduced to physiological saline. We looked at three different variables: the mass of sawdust, the temperature of physiological saline, we looked at room temperature and body temperature, and we explored two different particle sizes of sawdust. One that was smaller, about 300 micrometers in diameter, and a larger particle sawdust that was about 840 micrometers in diameter. Our preliminary results show that sawdust can be used as an absorptive media. As we can see, large particle sawdust, represented by the dark blue dots, absorbed more physiological saline on average than the small particle sawdust, represented by the light blue dots. We noticed in both cases the absorption is happening fast. Within 5 minutes it begins to level out. On average, sawdust absorbed about 3 grams of physiological saline per gram of sawdust. To give you an idea of what this number means, commercially available pads typically absorb about 10 grams of menstrual fluid per gram of material. Understanding the effects of temperature on the absorptive properties of sawdust, we can see that in small particle sawdust, there is a slight increase when the temperature is raised to 37 degrees Celsius. In large particle sawdust, however, there is a decrease from room temperature to body temperature. Further investigation is required to understand why this is happening. However, now that we have a better understanding of the properties of sawdust, we can begin to consider our second research objective, the design of a sanitary pad. Considering that the average menstrual cycle releases about 35 milliliters of menstrual fluid, we would need approximately 3 to 4 grams of sawdust per pad. We use commercially available pads to develop the pad dimensions. We also explored reusable and disposable designs. Our prototype uses gauze, sawdust, and muslin. We use muslin as a hydrophobic bottom layer to ensure there is no leakage. We also explored different sewing techniques to ensure that sawdust stayed enclosed in the sanitary pad. In conclusion, sawdust can be used as an absorptive property for a sanitary pad. There is a slight decrease in the absorption properties of sawdust from room temperature to body temperature. Considering this, we would need about 3 to 4 grams of sawdust in each sanitary pad. We are using gauze and muslin to design our sanitary pad. Our future work focuses on disinfecting methods for sawdust, the effect of added force on sanitary pad while the sanitary pad is being used, exploring the appropriate testing temperature, which might be above or below body temperature. We'd also like to conduct a biodegradability analysis on the sanitary pad after it is disposed of. And lastly, we'd like to explore the local sourcing of materials and perhaps additional easily sourced materials that can be used in sanitary pads.